Thank you for being here. So let's start our class for this week. Let me first remind you about the exam date and time. So this is posted on the Canvas. So your midterm exam will be posted at noon on March the 7th, which is a Friday, and you will have 36 hours to finish it and submit it. That means it will be due at midnight on March the 8th, which is a Saturday. Okay, so the exam is a 36 hours exam. I don't care which time window you use. So you have the entire 36 hours to finish it. And if you go to the modules, so all the contents for the midterm exam are posted here. Okay, and today we are finishing the last module, risk and return. Okay, so let me first introduce this class practice for today. So if you just click on it and download it, you will see the file is actually a Word file. Okay, it goes like this. So if you can't see the Word file, please let me know. All right, so the entire theme for this module is about risk. So when we think about risk, so what could define a risk? In the previous chapter for bond, so if a company got default, they have bad financials, they don't have the cash to pay off their debt, that's called a default. So the possibility of default is risk. So this option A is correct. All right. B, due to system-wide influences. And this is also called a systematic risk. Okay. It's a market-wide risk. Okay. Market-wide risk. And this usually applies to stocks. And in fact, if you are using capital assets pricing model, and that is related to the market-wide risk. Okay. And risk can also be defined as the variability of returns. Sometimes you have good returns, sometimes you have a negative return. Like on October the 16th, it's called in 1986, it's called the Black Monday. The entire market went down by 26%. So that's a risk. So all of these are correct. So the first one is more like for bond risk related to default of the company, bad financials, and the second one is for the stock risk. It's related to the market, and also the variability of returns, no matter for bonds or stocks, are all risk. So the correct one should be D. All right, talking about the systematic risk, we need to use a capital assets pricing model. It's called a CAPM. So if you Google search it, it's everywhere. All right. It's everywhere. So right here, I have a picture of that. The expected return of the stock equals to the risk-free rate plus the stock's beta times the market risk premium, which is the expected return of the market minus the risk-free rate. You can use this as a prediction of an individual stock's return. The individual could be Tesla, could be Amazon, could be Nvidia, and all these stocks. And each stock has its correlation with the market. For example, right here, you have a stock has a beta of 0.8. Let's say a lot of financial companies, they have a lower beta. I mean, beta lower than 1. And then the risk-free rate is 5.5%. The market risk premium is 6%. So what is the stock's required return? So you should use a 5.5% plus the beta of a 0.8, okay, times the 6%. All right. So 6% is a market risk premium, is actually the market return minus the risk-free rate. So the market return, if I do the calculation, should be 11.5%, and then minus 5.5% of a risk-free, you get a 6%. So the tricky part is it is already given to you for the market risk premium. So you don't have to use 6% minus 5.5. Okay. You don't do that. Okay. You don't do that. Okay. So you don't minus 5.5 because it's already given to you. All right. So let me just mark it here. You don't do that. Just directly use a 6%. And then the whole thing should be 5.5% plus 6 times 0.8, that's 4.8%. So this should be 10.3%. So that's the answer. All right. So the 0.8 is the beta. And if you scroll it down, the next question is a stock's beta measures the average return of the stock. This is incorrect because average return of the stock basically is the expected return of the stock. It's not the beta here. And B is correct. Okay. The level of the stock non-diversifiable risk. Okay, this is a very interesting term. Non-diversifiable basically means you can not avoid that risk by forming a nice portfolio. So if you have done assignment 2, you will know if you do a portfolio, if you combine two assets with negative return trend, so one goes up, the other goes down, so the risk of the two will get canceled. And that's called diversification. But the beta is about systematic return. Systematic risk, okay, is the market-wide risk associated with all the individuals. Okay, so this one is correct. You just remember this as a definition. So the beta measures the individual stocks non-diversifiable return or the systematic risk or the market-wide risk associated with it. Okay, so if you still don't understand, you can just take a look at this formula. The individual stock is right here, and this is the market risk premium, and this is the beta. So you can see if beta is a 0.8, that means when the market increase or decrease by 1%, then the stock would increase or decrease by 0.8% at risk premium level. Okay, and here could be a multiple choice question. So if beta is higher than 1, so that means when the market changed by 1% up or down, then the stock is changing by more than 1% up and down, so that means stock is more risky than the market. Okay, if beta is less than 1, then the stock is less risky than the market. So the market changed by 1% up or down, the stock changed by less than 1% up or down in the same direction. Okay. And beta could be negative. So if beta is less than 0, so that means the stock return goes to the opposite direction against the market. So if beta is negative, that means when market's going up, have a positive return, the stock has a negative return. Okay, or the market has negative return, the stock has a positive return. And the beta could be at 1. So that means the stock would change at the same level with the market. So the stock is as risky as the market as a whole. Okay, so when we talk about the market, it's the stock market. Okay, and the beta, if you analyze the beta, you can see that the beta is the stock risk premium. On one hand side, it is basically the stock return minus the risk-free rate. And I have told you what risk-free is in the previous chapter. That's the T-bills rate times the beta of the stock. Okay, times the market return minus the risk-free rate. Okay, so beta of the stock is measured this way. And also in your assignment 2, there is a separate Excel practice just to train you how to analyze the beta based on the past data. So you have a one stock's data and then the entire market's data, and then you try to estimate the beta. Basically, that's a coefficient between the stock risk premium and the market risk premium. So if a return minus the risk-free rate, then that's called a risk premium. It's the excess return of the assets. Okay, in addition to in excess of the risk-free rate. So this is the stock risk premium equals to beta of the stock times market risk premium. All right. So beta is fairly important. It is the system, it's determined by the market, and it cannot be diversified away by forming a smart portfolio. It's a market-wide risk, okay? Depending on different level of a beta, then you can see whether the stock is more risky or less risky or as same risky as the market, okay? And if beta is negative, that means the stock goes to the up direction against the market. All right, so that's the conceptual part with a little bit calculation. As I said, if I do this kind of class practice, then most likely these questions will appear in your midterm exam. Okay, so any questions so far? The concept of beta is everywhere. It's in your textbook. You can Google it. It's in Wikipedia. They have a similar conclusion, similar introduction. And this is developed by Dr. Harry Markowitz from University of Chicago. And this model, the concept of beta, helped him won the Nobel Economic Prize before. All right, then the rest part of this class practice is about calculation. And once again, you need Excel to do calculation. So let me start with an easier one. Let's see, share Excel. Okay, so I just copy paste this practice question right here. So you have 3 probabilities, and under each probability, you have a 1 return. Okay, so if you add the probability together, that's 100%. So that means there are only 3 probabilities available. All right, so under each case, you have a return. So how do you get the expected return? Based on the probabilities and the individual returns for each case. So if you get the expected return, you should use the probability times the return. Okay, probability times return. You get 1 product for 1 case. This is the yellow case, then red case, and blue case. So 3 cases, 3 products. The expected return would just be the sum of the 3 products. Okay, that's 8%. Alternatively, you can use sum of product function. Okay, so start with a sum and then use the probability column multiplied by the return column. Okay, hit enter, you get 8%. So either way, you can either create a separate column like this using probability times return and then add them up, or you simply use a sum of product function. The standard deviation is the measurement of a risk or the variability of returns. So how do you get a standard deviation? You would first get a deviation, okay? Deviation is each return deviate from the expected return of 8%. So I'm going to log this expected return. 25 minus 8, that's a 17. 10 minus 8, that's 2. Negative 15 minus 8, that's a negative 23. All right, it's called a deviation. And then you need to get the squared deviation. Okay, squared deviation. So each of them takes the square of 2. Okay, shift number 6, that's the caret 2. All right. You know, square deviation basically is a percentage, 2% multiplied together, which does not make sense. But we still have to go through this as required by the statistical formula. All right. And then you will use each probability multiplied by the squared deviation. Okay, probability times the squared deviation, and then drag it down. And then eventually you will need to sum them up, add them all together. Okay. And this is called a variance. Variance is the summation of all the probabilities multiplied by their respective square deviation. And the standard deviation is a square root, okay, square root of the variance. Remember previously we take the square, now we get a square root. So this is the standard deviation. This is how we measure risk in the profession of finance. Okay, you can use one single Excel formula, just call it square root, and then you will use the probabilities multiplied by each of the return minus the expected return. But remember, after the subtraction, you need to take the square. Okay, so that's not done yet. After that, you need to take the summation of all the products, okay, which are the probability times the square deviation, close the summation, close the square root, and then this is how it is done in one single Excel formula. All right. So either way, if you are savvy with Excel, you can use this single line of formula, or you just need to get the deviation, then square deviation, then probability times square deviation, sum them up to get a variance, and take the square root of the variance to get a standard deviation. All right, it's your call. The thing is, there is no easier path than this, okay? Once you have all these probabilities in your case, okay? These are all probabilities. So if you get a probability involved, things are getting hard for calculation, okay? So this is the process you need to go through. And in your exam, I may give you 5 probabilities, or I just stay with 3 probabilities. You take the same steps. And the goal is to calculate number 1, the expected return, and number 2, the standard deviation. So this is what I will ask you in an exam. All right, so back to the work document. Right here, you have 3 years of data. So let me copy it and then paste right here. I think somebody asked a question. I will get you. Don't worry. Chat. Having an Excel ton is there anyway? Make notes on Excel. Oh, don't worry about it. So after this class, I will save this Excel file and upload it on the Canvas, so you have something to follow. You will have a template. So just in case you haven't used an Excel, you have some template to follow. I hope that would help you. All right, so back to the practice question. So this is another one. This one is actually pretty easy. Do you have a probabilities like 20% in case A, 6% in case B? No, you don't. Instead, you have a 3 years, or in some other cases, you have several months. In your assignment 2, you have like a 50 month. All right. Okay. So once you have a calendar returns, I call this calendar returns, not scenario returns. So these are scenario returns. So once you have calendar returns, thank God, it's going to be very easy. So to get the expected return, you just get the average. That's it. You don't have to use a sum of product, just use average. All right, use average. To get a standard deviation, you don't need to get the deviation, square deviation, probability times square deviation. You don't need to do that. Just do STDEV. All right, and then you select the returns. That's it. Nice and easy. Okay, so you will do more practice in assignment 2 to get all the returns. All right. Once you have a calendar return, instead of a scenario return, then things are much easier. And be careful, if you are calculating the standard deviation here, make sure it's STDEV or STDEVS, you get the same result. If you use STDEVP, you will get a different result. So the difference here is STDEV basically is equivalent. Let me just put it here. STDEV is equivalent to STDEVS. The letter S, the last letter S, stands for sample. Okay, so that means the 3 years of return is just a sample of this asset's history. This asset could last for 5 years, could last for 100 years. Like AT&T has lasted for 100 years. And Mellon Bank in New York has lasted for like 300 years. So if we analyzing only 3 years of its return, I'm using a sample, okay? And STDEVP, P stands for population. So that's the whole population. So if this stock only lasts for the 3 years in the past, it got this IPO in the year of 2022, and right now it's the 3rd year, so it only have 3 years of returns. So you should use STDEVP if the available returns represent the entire population. Okay, so just let you know. So this is how you calculate risk. So basically, risk in this chapter is a variability of returns, and you can use a standard deviation, calculated standard deviation to represent the risk. So if I change the number here, so if it's 20%, and this is a negative 20%, oops. And if this is a negative 50%, you will see the standard deviation gets enlarged. So that means the variability of the stock returns is getting larger. So there's more uncertainty, there's more spread of the returns. So there's a higher risk. Okay. So that's the calculation part from this chapter. I think this one would be more challenging if you are calculating the scenario returns, okay? Because you do have to incorporate the probability in your calculation of expected return and standard deviation, okay? But for calendar returns, no matter you have 3 years or 50 months, or you have 1,000 days, it's just a matter of getting the average and then STDEV to get the return and risk. All right. The next one in your practice is this one. So let me copy this and post it to an Excel. This time you have 2 stock returns and 5 years. And you want to get the expected return for each, okay? Expected return for each. So what formula do you use? Yes, average. So average of all the returns in the column, and then drag it to the right, all right? To get the risk is standard deviation, STDEV, is the Excel formula. Select all the returns that's given to you, do not include expected return. Okay, and then drag it. Okay, and then you will need to form a portfolio. Okay, and for my portfolio, I want to be as smart as possible. So let's say I start with a 40% in A, and 60% of my money I put in B. Okay, so these are weights. These are my weights. So 40 in A and 16 in B. So what I will do is to get the return of the portfolio for each year. Okay, A's return times A's weight. Make sure the weight is locked. Okay, F4 is the hotkey for locking. And then B's return times B's weight. Okay. And then I just drag it down. All right. And then for the expected return and standard deviation of the portfolio, I just simply select them and drag it. As you can see, the formulas are replicated here. And you're going to do the same thing in your assignments. So what's the implication? Okay, what's the implication? So I form a portfolio. You see the return, the portfolio return will be in the middle. The maximum 4% of the 12.4%, the minimum 4%, and 9% is just in the middle. So if I do 50-50, I use 1 minus that. Okay, if I do 50-50, so it's in the middle between 4 and a 12.4. If I use a 20-80, it's still in the middle. So 40-60 in the middle. But if you look at a portfolio risk, it can be lower than any of the risks. So you have two risks, A's risk and a B's risk. A's risk is a 22%, B's risk is 21%, but the portfolio is like half of that. Okay, so that's the beauty of it. So portfolio can diversify the individual risk away. So if you make a smart portfolio, okay, some of the risk of a stock A, stock B can be diversified away by making smart combination. And in your assignment, you are required to do a solver. So basically, you want to get the coefficient of variation, okay, which is risk, risk over return. Coefficient of variation. Okay, so it should be in number. Okay, so you can see that portfolio's coefficient variation is lower than A, is lower than B. Okay, 1.4 is lower than any of this. So that means the portfolio has the best risk return combination. All right. So is this a 40-60 my best combination? All right. Can the CV be lowered at some level lower than 1.4? So if I change it to 20 and 80, so it's not exactly make it lower. Okay. You can see that it's not making the CV lower. So lower is better. Lower CV is better. All right. So you can use the solver function is under data. And right here, solver. So you will need to change stock A's weight, okay, in order to minimize the portfolio CV. Okay, this can only be done by the computer, and then you solve it. All right, so keep the result. So you see that 36 64 is my best combination. That's the smartest thing I can do, the best thing I can do to minimize the portfolio risk and return combination to reach the best result. Okay, when you see 3664 is actually a computer generated number, it's very exact. Okay, so this part could be a multiple choice question. All right, like portfolio return will be in the middle, but risk can be lower than any of the two risks, and the portfolio can diversify the individual risk away, and the portfolio can have the best risk return combination, better than any of the individual assets. All right, so let me get back to the documents here. All right, so let me copy this one to Excel. Yeah, if you have any question, just feel free to stop me or send me a message on chat. Okay, so this one is about getting the portfolio beta. Okay, so you will see that portfolio beta will be in the middle as well. Okay, that means it's the weighted average. Okay, it will be in the middle as well. So there's no diversification effect. For the return is also the weighted average. Okay, so how do you get a weight? So right here, you have some money in Dell, some money in Ford, and some money in Walmart. Okay, so you need to first get your total investments. So you have 100 grand in the three stocks. And how do you get the percentage weight? You know, the weight is always in percentage. So you use each individual investment divided by the same total. Make sure your denominator is locked. All right, and then drag it down. Okay, percentage. All right, and for the beta, you use Dell's beta times Dell's weight in your portfolio, and then you just drag it down. Okay, and then you just get the summation, oops, equal summation of all these three products. So it is called a weighted average, okay, weighted average. So portfolio beta will be in the middle, it's the weighted average, just like how you calculated the portfolio return, okay? And this part basically is telling you portfolio beta is the weighted average, and also you need to know how to calculate the weights in this chapter as well as in a later chapter after the exam. So in a later chapter we will learn cost of capital. You have some money in equity, some money in debt, and you need to get the weight in percentage first. So what's the percentage in equity? What's the percentage in debt? Okay, but that's another issue we need to worry about later. Okay, let's see. Get back to the document. I think the hardest part has gone. And now let's talk about some other concepts. So risk preference. This chart tells you the risk preference of different individuals. The vertical axis is expected return, how much you can get from your investment. And horizontal axis is a standard deviation. That's the risk of your investments. Some people are risk neutral. Okay. So that means risk does not affect them. Higher risk, lower risk, they would get the same return. And some people are risk averse, as most of us are, as most of the markets is. So most people, the rational people, are risk averse. So what's the reflection of risk averse? What does the word averse mean? Basically, averse means hate. We hate to take risk. We hate uncertainty. All right. So that means for each additional amount of risk we are taking, we need to get some in return, and that is called required return. So for risk averse individuals, higher risk they are facing, the higher return required. Okay, that happens everywhere, right? You know, the stock market is riskier than the bond market, so the investors in this country require higher return from stocks than bonds. And the small stocks are riskier than average stocks or big stocks. Then we will require higher return from the small stocks than the big stocks. Okay, so you can see there is a positive relationship between risk and return. Positive relationship between risk and return. And you will see the three curves here: high risk aversion, moderate risk aversion, and a low risk aversion. So for high risk aversion people, that means if X value, the risk increased by a little, then they will require much more return. Okay, you see how steep this is? It's steeper than any of the other two curves. So that means, let's see, for more risk averse people, small amount of additional risk is accompanied by should be compensated with much higher return. Okay, still it's the same positive population, a positive population between risk and the return, but they're more sensitive. For a small amount of additional risk, they want a much more higher return. And for less risk averse people, so large risk should be compensated with, let me be consistent with the wording. So large amount of additional risk should be compensated with little higher return. They are less sensitive. Like this low risk aversion is flatter. So that means these people are less sensitive to risk, but still they're risk averse because in general, the slope is positive. Okay, just it's a flatter. That means for a lot of more risk they are facing, they just require a little bit more return, not a lot more return. But things are completely different for risk lovers. So the risk lovers, you will find them everywhere in, in Las Vegas. Okay. These are gamblers. Okay. These are gamblers. So that means if they're taking more risk, higher risk, they would require lower return. Okay. Why is that? Because when they take more risk, it's like an entertainment for them. Okay. They receive pleasure from risk. Okay, it's like buying a ticket for taking a roller coaster. So that risk gives them a natural pleasure. And a lot of us are risk loving people in our daily lives. People climb the mountain, take the risk, even though they may fall and die, but they still like to take the risk because that gives them the pleasure. Okay, so once they receive the pleasure, they will require lower financial return. Okay, so that's a negative relationship between risk and return. Okay, higher risk, lower return. Okay, they just have fun with that, and they would require lower financial return. So that's for the risk lovers, and they will not last long because they are irrational. Eventually, they will lose all their money. Okay, so basically, this part could be a multiple choice question. Okay, the positive relationship between risk and return only exists for risk averse people, and negative relationship is for the risk lovers. Okay, you know that the gamblers in Las Vegas, in all those casinos, they know in their mind that if they keep playing, they will lose money for sure. The house always wins. That's a fact. But they cannot resist playing because they receive risk as pleasure. Okay. And there's no way they can control it naturally unless they take my course. All right. Okay. So here is something for fun. So let's see, you are in Las Vegas and I am the house. All right. So you are in my casino and I'm just offering a very simple game to you. So for the first one, so we're tossing a coin. All right. We're tossing a coin. Uh, it's a 50% to get a head or tail. So option A, you just get $1 and leave with no risk. Okay. Option B, toss a coin, you will get $48 if it's a head, and you will lose $46 when it's tail. And C, your bets are bigger. So which one should you select? All right. You don't need
A.
to do calculation at this point. All right. So how many people say A? So just type your answer. It's a chart box. Let
I
me
will
know.
say A.
Okay, A. So again, 1. There are 23 students in the room. Okay. Some people choose C, A, B, A. Yeah, I can tell you from my previous experience, most of the students in my previous classes choose A, but still there are people choose C. Some people choose B. So if you are a financier and you know how to evaluate a project or simply a casino game like this, so you can calculate the risk. So let me just copy this into Excel. This part is not required. Okay, this part is not required. Oops. All right. So if you toss a coin, so you have a head and you have a tail, and the probability for each case is a 50%, 50%. And for B, you get a $48 if you're winning and a negative $46 if you're losing. If you get a C, 975 if you're winning and a negative 973 if you're losing. And if you're doing D, 47,866 if you're winning, 47,864 if you are losing. All right. So how do we make a rational decision? This is called a calculated risk. Okay. So you will need to get the expected payoff. Okay. Expected payoff. So what do? You just use the probability multiplied by the expected the payoff for each. And I'm going to log the probability before I drag it to the right. So it's $1 expected payoff for B, and it's $1 expected payoff for C, and $1. Oops, this is negative. My bad. Expected payoff for D. All right. However, if you want to do the standard deviation, let's say the risk you are facing here, or the variability of the payoff, clearly B is the lowest. All right. So how to get the risk here? So it's a long process. Just bear with me. It's a square root of summation of the probability, log them, okay, times each of the payoff minus is expected, okay? And then you will take the square of it, okay? Close the sum, close the square root. So that's $47 for the risk. So that's a 47 variation from the highest to the expected or from the lowest to the expected. And then since I log the probability, because that's applied to both all the 3 games here, okay, you can see the risk is getting higher for C and higher for D. If you do for A, the expected return payoff is 1 and you suffer no risk. So A should be your best choice. Okay, if you choose the options other than A, don't feel bad at all because a lot of us are born this way. At least you are learning more from those who naturally choose A. All right. Okay, so now let me get back here. For the second one, the ranking is the same. You can put the numbers in, the ranking is the same. So it should be A, B, C, and then D. All right. So the expected payoff for all of them are -1. Okay. The expected payoff for all of them are -1, but the risk is higher for B and higher for C, and D, it gets the highest risk. So that's the ranking. We want to avoid risk is the theme in finance. The theme in finance. All right, now let's look at the last one. This time I want to do another round of survey just to look at this question, and I want you guys to select as best as you can. So which one should be your best? All three of them are gambling, okay? So which one should be your best? Just take a look at it. All right, can you put your answer in the chat box? A, all right, awesome. All right, awesome. I'm so glad all of you now are selecting A. Okay, I'm so happy about this. Why A is the best? Because now we know how to calculate risk, okay? And we only take risk when we get compensated for it. Why A is the best? Because A has a positive payoff, expected payoff. 48 is higher than negative 47 at absolute value. So positive payoff, and you can see the variability is the smallest risk. And the C has the most negative expected payoff, and it has the highest risk. Okay, so C is the worst, A is the best, and B is the mediocre, but we don't select B because B still has a negative expected payoff. So we don't select B if we have the ability to calculate the risk and the return. So A should be the one we select in our daily life. So the major takeaway is we don't go to casinos, okay, unless you really enjoy it, but I highly recommend against it because that's not very consistent with what we do in finance. In finance, half of our job is to avoid risk. And when we calculate the risk and the return, we make the best risk and the return combination. Okay. And I think that concludes my lecture today. So I will post this as well as Excel file on the Canvas. So it's pretty important for you to understand the concept, the risk, and how to calculate the stock return based on the CAPM, this model. So these are the given numbers, the information, and you should know the beta cannot be diversified away by doing smart portfolio combination, like changing the weight, 36%, 64%, that combination. That can diversify away some risk, but the beta, that risk is associated with the market. They cannot be diversified away because everybody in the market. All right. And the beta is association of the individual stock with the market. If it's greater than one, that means the stock is more risky than the market. If less than one, it's less risky than the market, and so on. And conceptually, you need to know how to calculate the expected return standard deviation, and it could be more complicated if you have scenario returns and a probability for each scenario. It will be much easier if you have calendar returns. And you also need to know how to calculate the portfolio return and the portfolio risk and understand why portfolio is something we want to do, because this can diversify away individual risk. So you can reach the best risk return combination when you have a portfolio. And the portfolio return is weighted average of individual returns. So is a portfolio beta. That's a weighted average of individual beta. And then you should understand that there are different risk preference. You see, when we first do this survey, some people choose C instead of A. So that means this person is less risk averse than those who chose A. Okay, so still these are risk averse selections. Okay, so risk averse indicates positive relationship between risk and return, and risk lover indicates negative relationship between risk and return. And for those who choose C right here, when you have negative expected payoff and highest risk, if you choose C, that means definitely you're a gambler, and you should tell yourself, don't waste money in Las Vegas in those casinos. Okay, you know the casinos, they always make money. So basically that's it. All right. So do you guys have any questions? So we still have a meeting next week on March the 4th. All right. There will be no additional content, no new stuff. So on March the 4th, I will do a review of all the 6 chapters. Okay. And I probably will go over all the questions here in a very, very fast pace because I expect you to have gone over all of them and finish all the required assignments. Talking about the assignments, you should have finished assignment 1 is due already, and I would highly recommend you to finish assignment 2 as a preparation for your midterm exam, because assignment 2 is within the curriculum covered by the exam, even though assignment 2 is due after the spring break. All right. Let's see. Any questions so far? Okay, if not, I would stop recording.